Alright, welcome back from spring break, guys. So today we're going to talk about exponential functions. And really, on exponential functions, you are going to take a Hawk certified over it, but I really just want to focus on the generic rules that go with it. And so it's not really the graphing, it's understanding like how does the graphing work within a Hawk's assignment. Okay, so exponential functions, we're going to identify the important properties of them. So definition is an exponential function with a base b is a function of the form f of x equals b raised to the x power, where b and x are real numbers such that b is greater than 0 and b cannot be 1. So if b is greater than 1, so examples 2, 3, 4, 5, 6, so on, okay? That's going to be called a growth, exponential growth. So that's the general shape of an exponential growth equation. If it's between 0 and 1, examples that you normally see would be like a fraction, 1/2, 1/3, so on, stuff like that. It's going to look like this. That's going to be exponential decay. So again, that's just a general shape of your graph, and we're going to do some examples so you'll see those. So the first one, it says graph the following functions with your calculator. Write down some of the characteristics that you notice for each graph. Instead of a calculator, we're actually just going to do it using the chart over here. Now notice the base is 2, which is greater than 1, so this should be a growth, so it should be going up. All right, so if I did 2 to the negative second power, which I would type into my calculator, I would get 1/4. If I did 2 to the negative first power, I would get 1/2. 2 to the 0 power, if you guys remember anything, the 0 power is 1. 2 to the first power would be 2. 2 to the second power would be 4. And I just replaced the x with the x values in my chart. So I'm going to go ahead and graph that. -2, 1/4. -1, 1/2. 0, 1. 1 goes up to 2. And then 2 goes up to 4. So the y-intercept is where it crosses the y-axis. And on this one, it's going to cross the y-axis at 1. Notice it never crosses the x-axis, so there are no x-intercepts. Our domain is how far left to how far right. When you think about this, it's going to go on forever, so that would be all real numbers. Our range, notice it never touches 0, that's the lowest point, but it goes up forever. So our range would be 0 to infinity. And we put a parenthesis on 0 because we never touch 0. Which means there's an asymptote at 0 because that's like an imaginary line that we never cross, and it's horizontal, so I would say y equals 0. Intervals where the graph is increasing, well, that's the whole graph because it should be going up the whole time as I go from left to right, and there are no decreasing intervals. So that's the basic characteristics of a growth function. Some key things you need to know is if it's 2 to the x, your y-intercept is very important to know, and knowing that it doesn't cross the x-axis is pretty important. And that'll change depending on whenever we do our transformations later on in the lesson. But those are the big things I really want you guys to focus on. And that it's a growth equation. Okay? So it says now graph the following exponential functions and compare them to the previous example. What do you notice about what they have in common? So what I did is I went ahead and I graphed those on Desmos for you guys. I'm just going to talk about them real quick. So 10 to the x and e to the x power. So if I go to those, 10 to the x, if you notice, it never crosses the x-axis. So it has no x-intercepts, which is like the one we graphed before. Also, just because the base is 10, the last one the base was 2, our y-intercept is still a 1. But this one is increasing at a much faster rate than the one that had a base of 2. So the way to think about it is the last one you're multiplying by 2, this one you're multiplying by 10. So it's going to increase faster. Or if you go to the left, it's going to decrease faster, but it's never going to hit 0. All right? Same thing with e to the x. So the natural base e, all right, we use this quite a bit. It also has a y-intercept of 1, and it never crosses the x-axis. So there are no x-intercepts. This one, e is about 2.78, so it's increasing around times 2, times 3, in between there. So it looks very, very similar to the one that we just graphed. So those are some comparisons as to what there is. So now, It says graph of y function with your calculator. 1/2 raised to the x power. So if I do 1/2 to the negative second, I should get 4. 1/2 to the negative first, I should get 2. 1/2 to the 0, anything to the 0 power is 1. 1/2 to the first is 1/2. 1/2 to the second is 1/4. So if I graph those, notice this one looks more like a decay problem. And our base is less than 1 but greater than 0, so that's called decay. However, the y-intercept is still 0, 1. And the y-intercept's not going to change by your base. This just means instead of multiplying by 2, we're dividing by 2. If you multiply by a fraction, that's like division. Again, there are no x-intercepts. Our domain is still all real numbers. Our range is still 0 to infinity. The asymptote is still y equals 0. Right? That's an imaginary line that we don't cross. This time there are no increasing because it's decay. It's just going to be decreasing the whole time. All right, so again, big things to keep an eye on. The y-intercept is still the same. There are no x-intercepts. And this is a decay problem because it's a fraction. So, properties of exponential functions. I don't know if you guys have noticed this. The domain is going to be all real numbers. Your range is depending on where your asymptote is. But for ours, it's going to be 0 to infinity. This is a general rule. If it's a growth problem, it's going to be increasing the whole time. If it's a decay problem, it's going to be decreasing the whole time. Your y-intercept is usually 1, unless we move it up or down, and we'll talk about those. And your horizontal asymptote is usually 0, unless, again, we move it up or down. So, right here is all the transformations that you're going to see. So A represents a stretch or compression. Right? And if it's bigger than 1, right? So if A is greater than 1, that's going to be a stretch by that factor. If A is between 0 and 1, aka a fraction, it's going to be a compression by factor A. Reflections, all right? If you remember, if there's a negative out front, that's reflect over the x-axis. If there's a negative in the exponent, that's a reflect over the y-axis. So negative in exponent is reflect over y, and negative out front of b is a reflect over the x. Your horizontal shift is in the exponent, right? If it's negative, that means you're going to go right. If it's positive, that means you're going to go left. Remember, they're lying to you whenever we do horizontal shifts. We've done shifts before. That's just the way it is. And then your vertical shift is k at the end here. If it's positive, that's going to be up. If it's negative, that's going to be down. Okay? So those are all the transformations we kind of talk about. And as long as you know the general rules for transformations, you should be able to graph it and kind of get the general shape of it. So it says graph the function with a calculator, 2 to the x, okay? Identify the transformations, identify the domain and range, identify the function as a growth or decay function, give the horizontal asymptote, and confirm results by graphing with a calculator. And we'll check these on Desmos. So if I had 2 to the x compared to 2 to the x power minus 1, this right here is going to be a horizontal shift, and that's all that we have. So this one's going to be a horizontal shift, and it's going to go right 1. So think about what that's going to do to your graph. So your domain is not going to change. It's still going to be all real numbers. Your range, just because I move it right, doesn't change the range, so it's still going to be 0 to infinity. This is a growth problem because look at your base. My base is 2. The horizontal asymptote is still 0. The horizontal asymptote only changes if I move it up or down. Now, whenever we graph this, I really want you to focus on, all right, the y-intercept. Normally it's 0, 1, but if I move it right 1, that means I'm going to add 1 to the x value. My y-intercept should be 1, 1. Okay? So let's go graph these on Desmos, compare them. So we have 2 to the x and 2 to the x minus, I gotta put this in parentheses, x minus 1. All right, so if you notice, the y-intercept is 0, 1 on 2 to the x, but when I move it right 1, my y-intercept is now 0, 0.5, but notice the y-intercept, the original one, goes to 1, 1, and that's what I meant by earlier. Your y-intercept went from 0, 1 to 1, 1. Doesn't mean it's the new y-intercept of the problem, but it like went over right, and so that's a good marking point to help you pick out the correct graph whenever you're doing the Hawks assignment. And that won't be until later, but it's just nice to know the graph. So I just moved everything right 1, so I took my y-intercept, I moved it right 1. It's no longer your y-intercept. You have a new y-intercept, because if you think about it, this one was at negative 1, 0.5. I move it right 1, it's going to be 0, 0.5. Okay? So that's kind of the general rule that we're looking for. And notice, whenever I did that, my horizontal asymptote didn't change, my x-intercepts didn't change, my domain and range didn't change. I just moved the graph completely right 1. So then the last thing we do is something with a little more transformations in it. It's still 2 to the x, but now we're going to take that and we're going to move it left 3 and up 3. All right, left 3, up 3. Your domain is not going to change, so they're going to be all real numbers. Your range is where it's going to change. So if I move it up 3, my range is not going to be 0, infinity, it's going to be 3, infinity. This is going to be a growth problem because the base is still 2. The horizontal asymptote, notice we went up 3, so now it should be at y equals 3. And the big thing I really want you to notice is 0, 1. That's a good marking point. That's normally where the y-intercept is. Well, now we're going to move it left 3 and up 3. So we're going to look for that point at 3, 4. That's just a good marking point for us to see if we did it correctly. So I'm going to go back to it. Say 2 to the x plus 3, and then put plus 3 at the end. So notice it moved your horizontal asymptote to y equals 3. We took 0, 1. It should be now at negative 3, which is right here, 4. Right? And that's, again, that's just a good marking point for you to know what you did first. Okay? So, again, domain and range. Domain didn't change, but the range, I moved it up 3, so it's going to change the range in the horizontal asymptote. As long as you can know the transformations, you will be fine on the Hawks, and I'll show you what I mean by that. So I'm going to go to Hawks. I'm going to show you guys what we're looking for. So I'll go to my student dashboard. And I'll show you what you're going to see later on. This is not your assignment for this one. This one you're actually going to do some graphing. But just to kind of show you what I mean by can you see the transformations. So this one, it's 2 to the x, right? We know it's a growth problem, and it should have a y-intercept of 1. So like this one's decay, so that one's out. This one, the y-intercept's not at 1, because there are no transformations here. That's just a regular exponential growth problem. This one crosses the x-axis, so it has to be that one. And again, you don't really have to graph it. You just got to know the general shape. So like this one, 2/5, okay? We know that's going to be decay. It's going to be going down. All right, but negative x, do you see that? That means I'm going to reflect it over the y-axis. So that means instead of being a decay problem, now it's going to be a growth problem. Because if you think about this, this is my decay, but now I'm going to reflect it the other way over the y-axis. So now it should be going up, and it should have a y-intercept of 1. So this one has a y-intercept of 1. It went from a decay problem to a growth problem. Whenever you reflect it over the y-axis, that's what happens. And we'll see if we're right. And we are. This one, 2 minus 2 to the x power, that's a reflection over the x-axis. And then the 2 out front means I'm going to move it up 2. right? So this is what it looks like, but then I reflected over the x. So we're going to do reflection first. So I went from 0, 1. I reflected over the x. Now I'm going to be at 0, negative 1, all right, for my y-intercept. And then move it up 2. Notice this graph went from 0, 1 to 0, negative 1, and I moved it up 2. I should be back at 0, 1. This one is also in the same boat. However, notice they just say, oh, I went down to 0 and I went up 2. That's not correct because normally the y-intercept at 0, 1. So I went to 0, negative 1 when I reflected it and then moved it up 2. So again, as long as you know the general, this is what's happening, then you should be fine. This one's decay, but the y-intercept is still going to be what? 0, 1. So I would go that, submit it, it's correct. All right, so that's like the main thing whenever it comes to graphing. They're not gonna ask you like domain and range stuff. They just need you to understand what is happening. This one, it's a growth problem, but I'm moving it right 2. So my y-intercept's not gonna be at 0, 1 anymore. Instead, it should be at 2, 1. Do you see this? I moved it from 0, 1 right 2 to here, and I know it's gonna be growth because the base is a 3, so I know it's right. And we'll work out these problems later whenever it comes down to it. So again, graphing, just do you understand the general shape? This is a decay. However, I move it up 3, I move it left 2, and I reflect it over the x. Or sorry, the y. So it was decay, but now it's going to be a growth problem, so it's got to be one of these 3. I moved it up 3. All right, so we were at 0, 1, but then you moved it right 2. So again, as long as you understand the general shape, you should be fine. So that's just what you're going to see. That's really it for the lesson. There's some more notes with some more examples that I would check out on the Certify, and then you're going to have a paper assignment. So if you guys have any questions, please let me know. Be more than happy to help.